this given question, in the given figure, OP, okay, OP, OQ, whatever rays are given, okay, OP, OQ, OR, and OS are 4 rays, okay. So you are having given 4 rays. Now you have to prove that all the angles that are made with these rays, the sum of the angles will be equal to 360 degree, okay. That is POQ plus QOR plus ROS plus SOP, okay. These sum, the angle of these sum will be 360 degree. Now how we are going to prove it? Shazan, any idea how we are going to prove it? Till now we have covered the axiom, which says that if a ray is standing on a straight line, the angles adjacent to it is going to make 180 degree angle. The sum of the
axiom, which one?
Axiom 1, okay, in this triangle, okay. And now what we can do for proving, here you cannot see a straight line, okay, full straight line. So what we are going to do, we are going to extend this OQ, okay, till M, okay, till M or whatever name you can give. I have written here M, okay. So you can extend it to M, as you can see in the below figure, okay. Now this MQ will be a straight line or not? Yes, this MQ will become a straight line. Now since it is a straight line and a ray OP is standing on it, okay, so that means MOP plus POQ will be equal to 180 degree. Linear pair axiom, okay. Yes, Arham and Shazan, I draw the figure.
This one.
What was your figure?
Oh, there you got washroom.
Yeah.
Good.
This is P, this is S, Q. Okay. Now I am extending this line. You can everybody else join. So let me just explain the question. Okay. Now we are solving question example number 12. Okay. Advika, Razi. Okay. Now in this question is given in the given figure. You can see the figure where you can see 4 rays are there. Okay. OP, OQ, OR, and OS. Okay. These are the 4 rays. Okay. Now the sum of the angles that are made with the help of these rays. The sum of these angles should be, we have to prove that it is 360 degree. That is angle POQ plus QOR plus ROS plus SOP will be equal to 360 degree. Okay. Now how can we prove that? For that, you can see here, till now we are having axiom 1, axiom 2, and one theorem. Okay. That vertically opposite angles.
Remember, isn't there like a theorem that says that the sum of angles around a point should be 180 degrees?
Yeah, but here
it should be 360.
Yeah, it should be 360 here. And they actually, through this point, there are many, you can say many angles, many rays are passing. Okay.
Ma'am, also can we also do that angle MOP plus angle POQ forms one linear pair, and the other one where angle MOS plus angle SOA plus angle AOQ also form a linear angle. So 180 plus 180 is 360. That's why.
Yeah. In fact, because we are going to do that only. See, in the main figure that is on the top, M is not given. Okay. So actually, we have made a construction that here you can see a straight line. So what I'm doing, I'm extending this OQ till M. Okay. Now we can see this is a straight line. Okay. And since it is a straight line, these 2 angles are going to make 180 degree or linear pair angles. Linear pair axiom. From linear pair axiom. Okay. You can see the sum of angle MOP plus angle POQ will be equal to 180 degree because MQ is a straight line and a ray OP is standing on it. Okay. So from linear pair axiom, we find that MOP is equal to MOP plus POQ will be equal to 180 degree. Similarly, with the same line, MQ, a ray OS is standing on it. That means angle MOS plus angle SOQ will be equal to 180 degree. Okay. Okay. Again, the linear pair angle. Now, if you see here, SOQ, but SOQ will be equal to what? SOQ will be equal to angle SOR plus angle ROQ. So we can write angle MOS plus angle SOR plus angle ROQ is equal to 180 degree. I'm taking this as equation 1 and this is equation number 2. Now, I'm going to add both the equation. Adding equation first and second. Okay. Now, if you add equation first and second, now this equation will be added and this equation will be added. So you can see 180, 180. So what we will get? What we will get? 360 degree. And on the LHS, what we will get? Angle MOP plus angle POQ, POQ plus angle MOS plus angle SOR plus angle ROQ will be equal to 360 degree. Okay. All I have written, I'll just shift it here, is equal to 360 degree. Now here, if you see where I was doing, Okay. Now this MOS and MOP can be written as SOP. Okay, because this M we have extended it and we have created angle. Now this MOP plus MOQ, MOP and MOS, and MOS. This you can write it as angle. I'm rearranging. Now this can be written as angle SOP. SOP or POS. Now you can see hence proof. SOP plus POQ plus RO. SOR plus ROQ is equal to 360 degree. Okay. So hence proof. Okay. Any doubt anybody? Shazan? Okay. You have to remember the axioms. Okay. If you remember the axiom, you are not going to face problem in.
Ma'am, do we have to remember the axiom like number also?
No, actually, you have to remember the whole axiom because if you're writing axiom,
Ma'am, I remember that. Ma'am, I am trying to I memorize the axioms with the number also, like first axiom, second axiom. Memorize like what is.
But we cannot just directly write axiom 1, okay? Because in triangle also you have axiom 1 and in the Euclids also you have axiom 1, okay? Do mention there from axiom 1 of triangle or write the full statement. That will be better, okay? From linear, every axiom have some short name also, okay? Like here, in your Euclids will not be having the name, but here if you see the axiom has the name. Where it is? Now here, you see the axiom. You can write it from here, sum of linear pair, okay? Just like this in this way, sum of linear pair. In this way you write, okay? Just directly don't write like axiom 1, okay? Now from here, the sum of this, or you can say from the converse of sum of linear pair, okay? In this axiom number 2. Now theorems also you have to mention. If two lines intersect each other, then the vertically opposite angles are equal, okay? Now, if you are writing theorem on axiom, so on the main book, how it is quoted, okay? Because theorem 1, theorem, in your this particular chapter also you'll find theorem 1, theorem 2. Next chapter again you'll find theorem 1, theorem 2, okay? So there's a series of theorems, okay? If you're writing just theorem 1, so which theorem you are referring, okay? So that will be a confusion for your exams, okay? So do write the theorems also, okay? Or a short form or the name of the theorem. Like Pythagoras theorem has a name. You don't have to write the full statement, okay? Converse of Pythagoras theorem, DPT, like this you'll find the names of the theorem, okay? So you can directly use the names of the theorem, okay? Now one more question, okay? This was from your the given figure AB. Okay, now you see the figure here. Okay, yeah, in the given figure, AB, CD are straight lines and OP, OQ are respective bisector of POD, and AOC. Show that the rays OP and OQ are in the same line. Okay, now what it is given, two lines are given that are intersecting each other, and it is also given that the angle bisector of AOC is OQ and angle bisector of POD is OP. Okay, this is given. Okay, now what you have to prove, that the OP, the line OP and OQ are in the same line. Okay, that means OP and OQ is a straight line. You have to prove. Okay, now how can we prove that OP and OQ is a straight line? Okay, we can prove OP and OQ is a straight line by proving that QOP is equal to 180 degree. Okay, since if QOP or POQ will be equal to 180 degree, that means it is a straight line. Okay, and it falls on the same line. Yes or no? And how can we do that?
AOC and BOD are vertical opposite.
AOC and BOD are vertically opposite angles. Yes. Okay. Now I'll just copy here. I'm copying just the figure. Okay. Now angle AOC is equal to angle DOB, vertically opposite angles. Okay. Yes. Now what we should do? The next one says, see, they both are vertically opposite angles. Now if we are taking half of AOC, I'm dividing both sides by half. Okay. Okay. Dividing by 2. Okay. So that means, see, AOC, half of AOC, you can take it as COQ. Okay. Because OQ is the angle bisector. So OQ is the angle bisector. That means we can write half of AOC as COQ equal to POD. Okay. Same way, half of DOB will be POD. Okay. We can name it as first. Okay. So now, if you see this line, okay, COD, so it is a straight line, okay, and AO is the way AO is on this, that means this will be equal to 180 degree linear pair axiom. Okay, from linear pair axiom we got that angle COA plus angle AOD will be equal to 180 degree. Okay, now COA, you can write COA as what? COA can be written as COQ plus angle QOA QOA plus angle AOD is equal to 180 degree. Okay, am I correct? Now the COQ you can write it as from here, from equation first. COQ can be written as angle POD plus QOA plus angle AOD is equal to 180 degree. Okay, now we have got POD plus QOA and AOD. You can rearrange it. In fact, you can want so QOA plus angle AOD plus angle POD is equal to 180 degree. Okay, so now this whole can be written as QOA plus AOD plus DOP can be written as QOP which is equal to 180 degree. Okay, hence QOP is a straight line. Any doubt?
No, ma'am.
Anybody any doubt?
No.
So let's see. Now we are starting with topic 2. Okay, parallel lines and a transverse lines. Okay, so here we'll be studying about parallel lines and transverse line. Means when a transverse line is passing through two parallel lines, that what are the angles should be common, the alternate opposite angles, the corresponding angles, all these things we'll be studying here. Okay, now before that we should know the meaning of these two terms, that what are parallel lines, what are transverse line. Okay, parallel lines, everybody know? Who is going to tell me the definition of parallel lines?
Two lines on which does not intersect each other and goes in a straight line forever.
Yeah, two
Except to be meet at infinity.
No, we are not going to meet at infinity. Also, generally, because the
When people say that it meets at infinity,
yeah, actually, it is said because they are why it is said they are going to meet at infinity. Because they are actually not going to meet, because the perpendicular distance between the two parallel lines will remain same from the starting to the end. Okay, that's why they say that they are going to meet in infinity. Okay, because we are not going to see them meeting. Yes. So the two lines are parallel if the perpendicular distance between the two lines are same throughout. Okay, and they don't meet, they don't intersect at each other. Okay, and you are correct. It is said that way only. The statements are written in that way only, that they are going to meet at infinity. Shazan. Okay, so what a transverse line now? Transverse line, if there are two lines, two straight lines are there, and a line, two straight lines are there. It does not say parallel. Okay, two straight lines are there, and a line cut these straight lines at some point. Okay, then this line is called transverse. So this L, suppose this is M and N. So L is a transverse line. Okay, L is a transverse line. Okay, read out.
Okay.
Now, when
Transversal has to go through two parallel lines, right?
see, when they are passing through parallel lines, then for the angles, we have a fixed means which angle will be equal to what. Okay, but it is not fixed that it has to be passing the transverse line. We see the definition, you can see here, a straight line which cuts two or more straight lines at distinct points. Actually, this is the definition for transverse line. Okay, two distinct points. Okay, then it is a transverse line. Okay, and for two parallel lines, we'll be studying when the transverse line is passing through two parallel lines, then certain angles are equal to each other. Okay, but if they are not parallel, so these angles we cannot just say that they are going to be equal. Okay, now let's see okay, now here when the two lines when the transverse line is passing through the two lines, okay, see there are many angles that are formed. Okay, there are total 8 angles that are formed. Okay, at first point when the transverse line is passing through the first line, you can see 4 angles. Okay, 2 angles on the upper side and 2 angles on the interior side. Okay, angle 1, angle 2, angle 4, angle 3. Okay, and the same way when the transverse line is intersecting the second line, then again 2 interior angles are formed and 2 exterior angles are formed. Okay, so total of 8 angles will be formed. Okay, now in these 8 angles, 1, 2, 8, 7 are exterior angle. They are on the outer side, so they are exterior angle, and 3, 4, 5, 6 are the interior angles because they are forming on the interior side. Okay, now let's see some definition. This means what these angles are called. Okay, every angle have a different name. Okay, they are in the category of angle. Okay, so corresponding angles. Now, which type of angles are called corresponding angles? The angles on same side of a transverse are known as corresponding angles. Okay, if both lie either above the two lines or below the two lines. Okay, if both lie above the two lines or below the two lines. Okay, so now in the figure you see angle 1 and angle 5. Angle 1 and angle 5 are the corresponding angles. Okay, because they both are on the same side and both are above the line. Okay, you see from both the line, M के जो angle 1 है वो M के above है, angle 5 जो है वो N के above है, and they are on the same side. Okay. So angle 1 and angle 5 are the corresponding angle. Similarly, angle 2 and angle 6 are the corresponding angles. Okay. Now, angle 4 and angle 8 are also corresponding angles. Now, this time they are on below the line. Angle 4 is below the line M and angle 8 is below the line N. Okay. So angle 4 and angle 8 are also corresponding angles. Angle 3 and angle 7 are corresponding angles. Okay. Any doubt in corresponding angles? Don't get confused with alternate angles, corresponding angles. In alternate angles also you'll be having categories in alternate interior angle, alternate exterior angle. Okay. Because when you're proving, you have to mention why these angles are equal, because they're corresponding angles. Why these angles are equal? Because they are alternate opposite angles. Okay. So you'll have to mention why you are taking two angles are equal. Okay. So these names should be, you should remember the names. Okay. What are corresponding angles? Okay. So anybody, any doubt? What are corresponding angles?
No.
Okay, so remember the definition: the angles on the same side of a transverse. Okay, and if both the angles lie above or the below. Okay, for example, now angle 1, angle 2. Okay, these are, I'm mentioning with different colors. Okay, angle 3, angle 4. Okay, which will be equal to which angle? Okay. So these are what? Corresponding angles. And which will be corresponding to which? I have marked with the same color. But angle 1 will be corresponding to angle 2. Angle 3 will be corresponding to angle 4. Angle 5 will be corresponding to angle 6. Angle 7 will be corresponding to angle 8. So you don't get confused. Okay? Understood? Now, let's see about another. Alternate angles. Okay? Now, what are alternate angles? Alternate side. Okay? Now, in alternate angles, we have three categories. Okay? Now, first, let us know about alternate angles. When two lines are crossed by another line, the pair of angles on opposite side of the transverse is called alternate angles. Opposite side. Now, you can see 2 and 4. Angle 2 and 4 are the opposite angles. Angle 1, alternate opposite angles. Angle 1 and 3 are alternate opposite angles. Okay. Now, alternate in this alternate angles, you will find three categories. The first one is alternate interior angles. Okay. Now, I'll copy the diagram here. Okay. Now, alternate interior angle. The following pair of angles are called alternate in which pair? 4 and your 6. 4 and 6 are alternate interior angles. Okay. 4 and 6 are alternate interior angles. Now, similarly, 3 and 5 are alternate interior angles. Now, again, I'm going to draw the diagram or get confused. Okay, alternate angles. Okay. So, interior angles. Okay. 4 and 6. Okay, these are your interior angle, alternate interior angles. Similarly, this and this are your alternate interior angles. Okay, understood? So with I'm marking it with orange and with your green. Okay, alternate interior angles. Okay, alternate exterior angle. Now exterior angle. Okay, this time we are taking interior angles. Alternate interior angles. So we are taking the interior portion. Okay, अंदर वाले side में हमने लिया है. ठीक है, अंदर वाले side में अगर आप alternate opposite angles देखोगे, so आपका ये वाला angle 4 and 6 are alternate opposite angles. Yes or no? Since we are talking about interior, so we are taking internal part. Okay. Similarly, this orange one also you can see. Okay, that is angle 3 and angle 5. Okay. Now for exterior angle. Alternate exterior angle will be what? 1 and 7. 1, this one, and this one. I'm marking with pink and yellow. I will mark. Okay. Now, any doubt? I'm marking the different colors.
Wow.
When you see the notes, so you can just. Okay. So for exterior angles, alternate exterior angles, angle 1 and angle 7. They are exterior angles. Okay. If I mark the values here with blue only. Okay. 1, 2. Okay. So 2 exterior angle, 2 and 8 are exterior angle, 1 and 7 exterior angle. Okay, understood? Now, let's see for now interior angles on the same side of a transverse. What? Interior angle on the same side of the transverse. 4 and 5, 3 and 6. You see here only interior angles on the same side. Okay, so if you see which color I use. Okay, so on this side, is it visible? And on this side. Okay, so these are interior angle 4 and 5, 3 and 6. Okay, interior angles on the same side of a transverse. Okay, the pair of interior angles on the same side of a transverse are called consecutive interior angles. Okay, don't get confused when you are proving. So if you are proving that angle, the interior angles on the same side are equal. So you have to mention their consecutive interior angles. Okay, aligned angles, or you can mention this also co-interior angle. Either you can write consecutive angles or co-interior angles. Okay. Now, Now it's the turn of your axioms and theorems, okay, which are the main parts, okay. You have learned about the definition that what are the angles. You should know which angle you are taking, the what are corresponding angles, what are alternate angles, okay. Alternate angle also you have categories, alternate exterior angle, alternate interior angle, co-interior angles, okay, or corresponding angles, okay. Now some axioms and theorem. Now, if line M is parallel to, now be careful that here the two lines, the two lines that are not only straight, they are parallel lines, okay. The transverse line is passing through the parallel line. These axioms and theorem are to be followed when the two lines are parallel lines, okay. Don't take for any other lines, okay. When line M is parallel to line N and a transverse L intersect them, then the relation between the angles. Now we are going to find the relation between the angles. What is the relation between these angles, the different angles, okay? And which angle will be equal to which, okay? Now, axiom 1, if you see, if a transverse intersect two parallel lines, then each pair of corresponding angles is equal, okay? So this is sure that if a transverse is intersecting two parallel lines, then each pair of corresponding angles is equal. Each pair of corresponding angles means one will be equal to 5, angle 2 will be equal to angle 6. See the figure. Angle 1 will be equal to angle 5, angle 2 will be equal to angle 6, angle 4 will be equal to angle 8, angle 3 will be equal to angle 7. When it is talking about corresponding angles, then all the means all the pair of corresponding angles means all the pair of corresponding angles. So 1 is pairing with 5, okay? 1 is pairing with 5, so this 1 will be equal to angle 5. Angle 2 is pairing with angle 6, so angle 2 will be equal to angle 6. Okay, why I'm saying pairing with 6? Through the corresponding angles. Angle 2 is corresponding angle to angle 6. Angle 4 is corresponding angle to angle 8. Angle 3 is corresponding angle to angle 7. Any doubt? So it is proved that this is an axiom. You don't need to prove. You can directly, if it is written that the two lines are parallel and through that parallel line, one transverse line is passing, so you can directly write what? That these corresponding angles are equal from axiom 1, okay, from the axiom 1 of trigonometry, lines and angles or triangles. Now this axiom 2. Axiom 2 is just the converse of the axiom 1, okay. What you have seen here, just the converse. What is the converse? Now, in the first one, it was given that what? That the lines are parallel and transverse is passing. Therefore, the corresponding angles will be equal. Now, the converse will be what? If the corresponding angles are equal, then the two lines from which the transverse are passing are parallel. Now, see, if a transverse intersect two lines so that a pair of corresponding angles is equal, then the two lines are parallel to each other. Okay? So, one is the exact theorem and one is the converse. Okay? Just the opposite thing it is saying. Okay? You can directly write from the, or you can write it here from the corresponding angle axiom. See, Advika, you are asking now that what we have to write when we are using the axiom. So instead of axiom 1, you are going to write corresponding angle axiom. Okay?
Yes,
and for axiom number 2, what you will write? In converse of corresponding angle axiom. Okay?
Yes, ma'am.
Okay. And everybody else also, when you are referring for, whenever you are proving and you need to mention axiom 1, so you are going to write corresponding angle axiom from corresponding angle axiom. And for axiom 2, you are going to write converse of corresponding angle axiom. Okay? Any doubt? Now, theorem 1. What does the theorem 1 says? If a transversal intersect two parallel lines. Okay? Now this time again, we are having parallel lines only. Okay? Everywhere you will be given parallel lines. And if it is not given that it is a parallel line, so you have to prove that it is a parallel line. Okay? So if a transverse intersect two parallel lines, then each pair of alternate interior angle is equal. First tell me what are alternate interior angles. Which angle are alternate interior angles? 3 and 5, 4 and 6 are alternate interior angles because we are talking about interior. So we are taking just interior one. Okay. Now, if we have to prove that if a line AB is parallel to CD and a ray R is a line R is a transverse line is passing through these, then the alternate interior angles are equal. Now, how can we prove that? Since you can see the two lines are parallel. Okay, so that means what? That the corresponding angles, all the pair of corresponding angles will be equal. Yes. So angle, if you see the corresponding angles, so first what we have to prove that angle 4 is equal to angle 6 and angle 3 is equal to angle 5. So now see here, angle 1 will be equal to angle 3. Vertically opposite angle, everybody in the figure.
Now angle 3 is equal to angle
1.
Okay, sir.
Vertically opposite angle. Okay?
Now, so can we say that angle 3 is equal to angle 5 and then angle 3 is also equal to angle 7?
Angle angle 3 is equal. No, how can you say that angle 3 is equal to angle 5? That only you have to prove, Advika. Angle
Ma'am,
3.
ma'am, so angle 3 is corresponding to angle 7 and corresponding angles are always
Angle
equal.
3 is corresponding to See, in that way you can prove. See, angle 3 is corresponding to angle 7. Okay, and angle
7
5
is
is equal to
vertically 5.
Okay, so that means angle 3 is equal to angle 5. That way
Yes,
you can do. In fact, that only I'm trying to do. See, 1 will be equal to angle 3, and the corresponding angle of 3 is what? 3 will be equal to 7.
Ma'am, 3 plus 7, ma'am. 180.
No, wait. Angles, you said that angle 5 is equal to angle 7. Yeah, vertically opposite angle. And angle 3 is equal to angle 7, corresponding angle. So angle, I'm writing here only. Okay, angle 5 is equal to angle 7, vertically opposite. Opposite angle. Angle 3 is equal to angle 7, corresponding angles. Okay, therefore, angle from equation 1 and 2, you can write angle 3 is equal to angle 5. Okay, the first is proved. Okay, now you have to prove that 4 is equal to 6. Angle 4 is equal to 6. Again, what you can do that angle 4 is equal to angle 8. Okay, and angle 4 and angle 8. Sorry, angle 8 is equal to angle 6. Okay, now angle 4 is equal to angle 8 because of corresponding angles. Corresponding angle and angle this is equal to vertically opposite angle.
Well, thank you,
So
ma'am.
therefore, angle 4 is equal to angle 6. So we have proved that interior angles are equal. Any doubt, anybody?
No, ma'am.
Shazan, Razi, and Hum. Razi, you have any doubt?
No, ma'am.
Okay. So understood? Okay. So I have used that 2 angles are vertically opposite and 2 angles are corresponding angles, and hence by joining means if you remember the axiom, if same are there was axiom exact statement I'm missing. Okay, if A is equal to B and B is equal to C, so therefore A will be equal to C. The same thing we have done here and we have proved it. Okay, and see, this is theorem 1. Okay, now you'll find a converse of the theorem. In converse, what you have to prove that if the alternate interior angles are equal, then the 2 lines are parallel, just the opposite. See, converse of theorem 1. If a transverse intersect 2 lines such that a pair of alternate interior angle is equal, then 2 lines are parallel. Okay, after this, I am just finishing. Okay, because time is almost over. Now, this is very simple. Now, if you can see what is given here, the transverse are intersect 2 lines AB and CD, PQ. Now, angle 3 is equal to angle 5, which we have proved in the last theorem. And it is given here that angle 3 is equal to angle 5 and angle 6 is equal to angle 4. Okay, now how can you prove that AB is parallel to CD? To prove AB is parallel to CD, if you remember the converse of corresponding theorem, corresponding axiom. Okay, so what was given that if corresponding angles are equal, one pair of corresponding and 2 pairs of corresponding angles are equal, then the lines are parallel. So we just have to prove a pair of corresponding angles are equal. Now, if you see here, angle 3 is equal to angle 5, but we also know that angle 3 is equal to angle 1. Yes or no? Angle 3 is equal to angle 1, vertically opposite angle. Yes, everybody? Angle 3 is equal to angle 1 because of vertically opposite angle. And it is given that angle 3 is equal to angle 5. From these 2 equations, we can derive that angle 1 is equal to angle 5. Okay, angle 3 is equal to angle 5 given, and this is equation 1. Angle 3 is equal to angle 1, vertically opposite angle. Okay, therefore, and you can take it as second from first and second. You see that angle 1 is equal to angle double I mark. Therefore, angle 1 is equal to angle 5. Okay, angle 1 is equal to angle 5, which are what? Corresponding angles. Therefore, what are line? Line AB is parallel to CD. Okay, understood? You mentioned this also. Converse of corresponding axiom. Corresponding axiom or corresponding angle axiom. Understood? Any doubt? From the corresponding angle axiom. Converse of corresponding angle axiom. Okay. Any pair you can prove. Okay. Any pair of corresponding angle you can prove that they are equal, and then you can, with the help of converse of corresponding angle theorem, you can prove that the 2 lines are parallel. Okay. Understood? I have proved that. See. 4 is equal to 6 is also given. So from that, you can prove that angle 2 is equal to angle 6. And through that also, you can prove that the lines are parallel. Okay. You just have to prove one pair of corresponding angles are equal. And because of that, we are going to apply the converse of corresponding angle axiom, and you can prove that the lines are parallel. Okay. Any doubt?